The SD Ruby podcast is brought to you by New Relic.
I am going to be talking about writing command line applications in Ruby. And just to scope this talk, it's if you've had experience as a sysadmin, there's nothing, you're not going to learn anything other than maybe how to implement ideas you already know in Ruby. But if all you do is really use the command line to run the Rails command, then you might pick up some stuff that's in this talk. So I'm Mark Ranallo. You can reach me on Twitter, Mark Dr. I'm not a doctor, it's just my middle initial. About me, from 99 to 04, I actually played video games for a living. It is a real job, and it's not as good as you think. And then I did PHP for a couple years after college. So the dark ages, but not really. I really have nothing bad to say about PHP. But now I work primarily in Ruby, and all I can say about that is it feels good. It definitely feels good. I work at Planning Center Online, and we do cool planning software for churches and nonprofit companies. So why would you write a CLI app, command line app? Well, eventually you're going to get to a point where you're just like drowning in scripts. You have like all these little tiny scripts that do one or two things, and it's good to consolidate those into one app so you can just maintain one thing as opposed to a bunch of one-off scripts. It's good to scratch your own itch. If you need something to get done, sometimes it's just best to do it yourself. It comes down to that. Allows you to pool together domain knowledge, domain logic. That sounds big, but really what that means is if you work in like a big company or something and you have DBAs, maybe the DBAs like databases to be deployed in a certain way. Rather than having a wiki where you have to like copy and paste the command to deploy the database in a way that pleases the DBA, you can just write a little app that you pass in the SQL file or whatever you want to deploy, and then it actually does all the finagling for you. So there's little things like that, like automating your working, which just makes things more pleasant. And if you do that, if you automate things, then it makes people that come after you a lot happier when they have to maintain things that you wrote. So why write them in Ruby? Sysadmins would just look at you sternly if you suggested it. Do anything in Bash. Do anything in Bash. Well, you can say to them that Ruby is gaining wider distribution. Even crusty old CentOS boxes can run Ruby. There's much better tools available, like debugging a Ruby CLI app is way easier than debugging a Bash script. The performance is respectable to good in just about every situation, unless you're dealing with stuff that is so large that you probably should be writing it in C or Java. And then that's kind of out of the scope of what I'm talking about. And there's distribution options. You can distribute it as a Ruby gem, which is really convenient for people. Or if you're looking to cut down on the amount of external dependencies, you can just distribute it as a standalone binary, using brew or something, or homebrew, sorry. And because we're Rubyists, that's why we're doing it. Okay, so now what? So I would suggest anyone that that works in Unix but hasn't really has an interest but hasn't really dived into it to maybe look at this book, The Art of Unix Programming by Eric Raymond. And it's filled with all sorts of knowledge from people that have worked in the industry before, and they pass down lessons learned, and this book is filled with them. And part of them are these rules, and it's kind of small, and I won't read through them all, but these rules are something that I like to even go through before starting a project, because it's just good to internalize them when you're about to work on something. Things like the rule of clarity. Clarity is better than cleverness. Things that we already kind of know, but it's good to reinforce them. So I'll be talking specifically about three of them. the rule of composition, which is design programs to be connected to other programs, the rule of least surprise. In interface design, always do the least surprising thing. And the rule of repair is when you must fail, fail noisily and as soon as possible. So we'll start with the rule of composition, which is design programs to be connected to other programs. And really that's kind of like the killer feature of Unix is tying things together. So we'll start with streams. And streams are super basic. There's three of them that you need to know about: standard in, standard out, and standard error. Standard in is it reads all the input from the user, or that was inserted into the application from another application. It's available in Ruby using the class stand-in or the standard in global. Variable. It's used internally in Ruby inside the argf class. So what do we call standard out and standard error? These are like the generic things that you, like when you put something on the screen, you're using standard out. When you print something, you're using standard out. Standard error is a way of using piping errors so that this operating system knows that they're errors. Same thing as standard in, they're available with the same convention in Ruby. And like puts use a standard out by default, but you can explicitly call standard out puts and standard error puts. And you say, well, why would I, like standard out's fine, why would I use standard error? But say you're running a cron job. Well, if you're running a cron job and it logs from standard out, it'll happily log all day long. When something goes wrong, if you write what goes wrong to standard error, then it's going to mail you with all the nice little things that you wrote in there saying what went wrong, which is what you want. You don't want it to fail to the log that you're not checking anyway. So that's kind of like a primer on why you would want to use that. Next section I'll go through is pipes. And pipes are really cool. Pipes are like a killer feature. Pipes are one of the killer features in computing that were invented. And if you don't think so, you just haven't used them enough yet. This is an example. Does anyone have a guess on what that does? It's a snippet I've actually used several times. It comes from my personal collection. But basically, what you're doing there is you're getting all the gem name, and then you're cutting all the versions after the space, and then xargs is a command that basically takes what you wrote, or what it takes in standard in, and applies it on the end, and then runs that argument. So basically what this does is uninstalls all your gems. So this is before like RVM gem set dump or whatever it is. This is how we used to do it. That is way cool. So here's an example in Ruby. This is super trivial, but I want to make it, I just want to show like it is easy to do these kind of things, make little small trivial apps. And if your app gets too complex, maybe you should break it up into smaller apps. That's kind of like Unix philosophy. Kind of like how we break models up. If a method gets too complex, you break it into smaller methods. Well, that was kind of their philosophy. Was if an app gets too complex, you kind of break it up into smaller apps. But this is the app I call the hollerizer. So what it's doing is it's taking standard in, and then just taking each line of it, and then attaching holler onto the end, and then passing in a new line. So it prints out new lines. So we'll do a little demo of let's see. There you go. LS, and I'll pipe LS through hollerizer. All right, look at that. So you can do stuff like that, I may pipe everything through this from now on. So, but that just kind of gives you a feel for what you can do. And if you have something where you need to you know, say you want to go through all the, you know, Git files. You can print out a list of files. You want to open them with some application. Well, you can write a little app that does that, basically. All right, so.
I have a question.
Okay.
If you're doing something that takes a long time, or let's say if you run a script or something that has several steps and it takes time to give out the lines, does it give the lines as it goes, or I mean the hollerizer? But just out of curiosity. Or does it buffer everything and then it spits everything out?
Well, okay, so I think by default, Ruby will buffer output up to a certain level. Forget the exact quantity of lines, but it will buffer it. But you could stream too. I mean, it's possible.
Then,
So what did the RDF do back in that small hollerizer script?
Sure.
Oh, sorry.
Holla. RF, basically what it does is, RF is everything that came into that app on standard in. So gem list threw everything to standard out, and then using the pipe, we redirected that into the hollerizer on standard in. And then RF took the lines from standard in and then printed them out. And then I redirected them back out to standard out. So there's demo. Another thing is environment. It's way cool if you can have your app take configuration from the environment in which it's running. So environmental variables, they're key value pairs, and you can use them to configure a process, basically. You know, there's this typical var equal val syntax. Variables are inherited from parent to child applications. Why that works in almost all of the applications you run now, you may think like, well, you know, if I just run something by default from the prompt, you know, it doesn't really have a parent. But yeah, it does, because you know, almost every application's parent at that point is bash or whatever shell you're using. So it inherits its configuration from that. And they'll act as globals within the process. So like if we were to run this from the command line, I won't actually go, but basically it's going to output hello SE Ruby. Because it's going to take that var equal val, it's going to take that message variable, and inside Ruby, that's available in the end construct. It looks like a hash, but it's not a hash. You can still you can check to see if it has a key, but it won't respond to all the things that a hash has. Here's a practical example, one you've probably used almost all the time if you use rescue. You know, setting the queue, but that just shows you how you can set configuration through environmental variables. Okay, so now we're on the next rule. Rule of repair: when you must fail, fail noisily and as soon as possible. We like to have exit codes. The exit codes are kind of like the last thing, the last words of a process, the last thing it does before it, you know, bites the dust. It spits out its exit code and moves on its merry way. You know, the exit codes they range between 0 and 256. They happen whether or not you are explicitly, if you explicitly set the exit code when the program exits, then it's going to exit with that exit code. If not, it's still going to have an exit code. It's still like the operating system is still going to assign one to it, to the process. They go up to 256, but you're almost always going to be concerned with 2, 0 and 1. 0, everything was copacetic, A-OK. 1, something bad happened. Yeah, so I'm concerned with 0 and 1. So this is just a simple program. You know, put simple program, then it exits. All right. So then that makes a call to Ruby kernel exit, and then exits with the 0 for everything is okay. And then if you've ever done any sort of DevOps or anything like that, and you're working with stuff that like goes through a process, several applications run in a sequence to perform a task or something, you might run into something like this, where you have a bunch of complex code going on, and then there's a condition saying, oh my god, this app is melting, it can't handle anything, and then it exits. The problem being here is it's still exiting with the code 0 saying everything's A-OK. So you're down the tool chain, you don't know that that failed. And then that's going to make you go like, ah! You know, you pull your hair out. So there's ways you can like not do that. So if you get to the point where you're handling conditions and you're rescuing from an error, and you want to exit the program, the process, if you just call exit with the exclamation point, that's going to exit with an error code of 1, just to be a good Unix citizen and let everyone else down the chain know that, hey, I failed, not good. And then you can use exit down there at the bottom, you'll see, and set the exit code right there. You can say, okay, I'm exiting, but with 1, something didn't go wrong. The advantage of doing it that way over the previous way is that you can set a block called @exit, and you can set some super helpful information about what happened when it failed or anything like that. And that block will get run after the program exits. So, next thing we'll go into is signals. Another part of being a good citizen in the Unix environment is, respecting signals. You can think of them as asynchronous communication between processes, or it's kind of one way between process. You use it all the time, whether or not you even realize you're doing it. You hit Control-C to exit a program or something, you just send a signal. Control-D, you send a signal. There are 3 possible things the process can do to receive the signal. It can ignore it, it can perform the predefined action, or it can perform the system default action. So, like if you send a kill, it's going to kill that process. If you ignore it, then the process is just going to be like, "Woo, on my merry little way, I'm oblivious to everything." So that's how most applications work. Oh, sorry. So here's a little chart of some of the more common ones you'll see. Like there's sig up, sig int, sig quit, sig kill, sig alarm, sig terb, and the number of assigned to them. You might be most familiar with 9 because if you kill 9, you remember this. Killing processes with extreme prejudice. That is kill 9. So to get the list of supported ones in your OS, you can just do kill -L. And different OSs will support different signals. It's not a real standard thing. But I mean, some of them are pretty standard, but there are a lot of variations. So this is OS 10 what it supports. So here's some Ruby code, a small app that traps for different signals and does different things. So basically, it just outputs its ID, its process ID, so that it's easier for me to find it. It traps under two circumstances, and if not, it just sleeps for 1,000. And the reason I did that is because this isn't you can demonize a process, and that's kind of a different thing. I'm not going to really get into that a whole lot, but that's where this is the most useful, is when you don't have direct access to the process. That's when sending signals is really valuable. So let's do a quick. So let's ls. Why not? Okay, so let's see example. Okay, so it's running on process. So, and then we'll send kill 15 to So you say it said, oh, okay, I'm going to terminate. Now you might have had some logic that was very specific to the termination of that process, that some cleanup that needed to happen or something of that nature. And so that's when that is really useful. And then we'll try the same thing. Oh, wait, it's on a different process. So, something triggered in that script. Now you can do things like, you can do sig stop. You could, if an application was running a long process, processing a large amount of data, and things weren't going right, but you built into your app, you could have it respect sig stop. You could send it a stop, and then it's going to stop what it's doing. You're going to check everything, make sure it's okay, and then you can send it a continue, and then it's going to continue where it left off. So, super useful. That's a little more advanced, but you never know when it's going to come in handy. All right, rule of least surprise. In interface design, always do the least surprising thing. Interface design seems kind of a weird thing to talk about when you're talking about command line applications, but it's really one of the more important things because there's some things that you want to do that you might not have thought about. That's it. So like, don't go over the top. Keep it simple. One element per line of output makes it play nicest with other apps in the toolchain. So if you can do it so that you have one meaningful piece of content per line, then other apps are going to find it very easy to interact with your app. Simple as that. And it's easy to mess this up. Like you could, you put in a bunch of dashes and try to get fancy with tables, views like that, which is absolutely great if you're not going to, if this app isn't going to be used as a part of any other greater ecosystem of apps. But if you have to like escape out a bunch of stuff, it gets to be a hassle. Avoid prompting for input if you can avoid it. So that means like always if you need a username or a password, like take it in the as an option at the beginning. Don't prompt for it because that just makes things a lot harder if you're trying to use the app with something else. And it's always useful to return help when a user runs these three things. If you just type in the application name and hit enter, most people will expect to see the help under that circumstance. Or if they use -h or --help. And just doing something as simple as that will make your tool a lot more maintainable for people that try to use it after you. So I want to talk about option parser a little bit. It's included in Ruby. The argument specification and the code to handle it are written in the same place, which if you've ever tried to use like REF to take the standard input and get the options out of that, it's hard. It's a hassle because you get a big array and then you've got to loop through it and it pops things off. It's not very maintainable. It makes optional and mandatory arguments very easy to do. And it will build the option summary for you, so you don't have to write code to output a pretty list of things that your app does. So here's an example of the hollerizer with options turned on there. You can see it just takes, you just pass in, you have a hash at the top, options, pass in the options, the options parser, then you go through and you set a banner, and that's kind of like goes across the top, gives a summary, and then each individual option, and then down below, you can see that, if someone is really verbose and they really are feeling the holler, then they can get 2 if they pass in the -b. Otherwise, they just get the standard 1. And so, yeah, and it's super easy, and you've already gone up an order of magnitude of usefulness to people just by including that simple little bit of code. So, okay, now I just want to go over some gems or helpers that you might find useful if you find yourself needing to write command line applications. Option parser, which I went over, is built in. there's Open3, which is built into 193, or if you're using Ruby 187 plus, you can use Open4. And basically what this does is if you shell out from your process to another process, if you do it within Open3, then you're going to get a clean standard input, standard output, and standard error to that other app, basically. It's gonna control that other application in a much cleaner manner than just using backticks, which only gets you the standard out from the application you ran. Readline, which is built in. That's good for tab completion. If you do prompts for input and you want the user to be able to tab complete things, and super useful. Herb, I use that in IRB a lot, but you can actually use it in a command line app. If your app is only going to just display data, it's really useful because it makes those big pretty grids that I was saying were kind of evil, but in certain circumstances it's really useful. Then there's Aruba, which allows you to write cucumber type steps for testing your command line application. This little example is, given you have an empty file, when you run move, it should exit with 0, and then file should exist and it should not exist. And then I put in a link if you want to read more about Aruba, because you can go into, you can talk a lot about that particular gem. There's a lot of information on it. Here's some more gems. There's Clamp, which is like it's like a framework for building command line applications. It has generators, will generate a lot for you. There's Boson, which is kind of like Thor, which Thor is kind of like Rake, but they all let you write kind of DSL for writing command line applications, kind of take away some of the grunt work, but including those kind of adds a dependency, so it's kind of what level you're comfortable with, how much dependency you want to put in the application. There's Ron, which is a cool way of writing. It lets you write man pages in Markdown, which if you ever try to write a man page and not in Markdown, it's really terrible. And then there's Gem Man, which allows you to put a man page inside your gem, which is really, really useful because if you pass your application off to a sysadmin and you get an email back like, what does this thing do? I don't know. You're like, well, did you look at the code? No, I typed man. It did not tell me. Well, they're going to expect, some people expect a man page, so there's that. If you're looking to read some more about this, I recommend these two books, aside from the book I recommended earlier, which is Working with Unix Processes by Jesse Stormier, and David Copeland's Building Awesome Command Line Applications in Ruby. Those are both good books. I can't recommend them enough. So thanks. That's it. I don't know if anyone has any questions. Sure.
In your first iteration of the hollerizer, could the RDF have been replaced with standard and dollar standard?
Yeah, it would work. Sure.
So do you have like a company command line library that's slowly like building up and you pass to everybody to do things within the organization? Or?
Well, we've been building some stuff. Like there's like things like, we have a process for staging the application, and it's one of those things where it got annoying doing that same process every single time. So you just write a little command line app that you type stage in a directory, it checks the Git, pushes up to GitHub, does all the stuff and deploys the staging branch, things like that. It's one line, made my life easier. Makes things like that make you happy. So.
I'm wondering, when you do that, do you just have like a whole bunch of little small scripts, or have you done any packaging? Like I'm thinking of like the Rails script where you do Rails whatever.
Right. You can package it as a Ruby gem, or like I was saying, it's like a homebrew. Because what I do is, let's see. So I usually keep in my code directory, I keep a binder, and this is where I put things. So you'll see. Like hollerizer, it's just a script. You make it executable. Put in the shebang at the top. I guess I should, let's see,
Becomes second nature, doesn't it?
yeah. Up at the top there, that tells the application to run it with Ruby, so I don't need to run Ruby hollerizer, you know. I can just make it executable and it runs. So, you know, you can do things like that. So I keep my own personal binder of applications, but you know, they're just like Rails and Bundler and any gem that you install that includes the executable, you know, there's ways to do it that way too. Yeah.
Do you use Rake or Tor or that third one that you said for different things, or you pretty much just use one?
I use Rake in the context of a Rails application. So normally when I'm manipulating with things inside of a Rails application, I don't usually use Rake to like run things outside of the context of the Rails app. I'm more likely to write my own script than I am to use Thor or Boson, but that doesn't mean those aren't good solutions. It's just, that's where I'm at, like my comfort level with things. So I recommend those to everyone here to try, and if you decide you like to write your own, then write your own. If not, you know, go ahead.
This is more a Unix question. If you're typing two commands and your first command shoots off an exit code in one, does the error go into the second command, or
No, it'll die right there. It'll break at that point, and then spit out like, you know, this process exit with code one. If it exits 0 but still has an error, then it will pass its error on down the line.
You can think of the pipe as being like it stops on an exit code
Right.
of non-zero.
Yeah.
Cool.
As long as it's 0, everything's going down the pipe.
That's correct, interesting. Or
Okay, is that it? All right, thank you.
That's one.